Hello, this is Mohammed, and I'm presenting some lightweight project I did about 8 months ago. It's my blinds tilt automation device. So I had these plants that require a regular sunlight exposure, and the idea was simple. I just wanted a device to keep track of time and open the till the blinds open in the morning and close them at night. And so I did it. And some of the objectives of this project is first I wanted to be battery powered, so that I can save myself the wires and adapter and everything. And also I wanted this to be my first low power project. And also I didn't want to do any modification on the blinds themselves because I live in a rent. Basically, I don't want to have to pay the full price of everything when I leave. So I just needed something to be attached to the wand of the blinds and just turn them open and close. And also I want it to be easily attachable and detachable so that this can be easily detached and used regularly and then put back. So the mechanical part of this project is composed of this 6 volts DC motor, which is attached to these gear series there that amplify the torque to provide enough torque to tow the wand. Also, this is configured such that it's easily, as I said, detachable and reattachable again. Also, there's this tachometer here to provide feedback to the control circuit. Also, the whole base, this base is spring loaded, so it can be pushed down easily and it can recoil back. The control circuit and the user interface. So the user interface is composed of 4 LEDs here, 3 red and 1 green, 3 buttons and 1 7-segment display, 4-digit 7-segment display, and a small buzzer to give warning to the user. The control circuit does 3 main functions. It keeps time and it has open time setting and close time setting, and all of these are user configurable. So the default state is that the control circuit is in sleep mode. It consumes very low power from the batteries and keeps track of time, and also it will activate the motor to open and close the blinds when the time comes. The user can wake up the circuit by clicking this button here, the wake button, and it will by default wake up in the clock setting. So it will display the current clock, and the user can scroll also to see the open time setting and close time setting. When we do this, this is the current time here in Sacramento. As you see, the time is displayed as 0 to 23 hours instead of the 12 a.m. p.m. And I did this to just save myself extra LEDs required because of the limited space I have on this board. So also by the time I was doing this project, I didn't have a clock configuration configured 7 segments display. So I just used the regular 7 segment displays, and I used the decimal instead of the two dots to separate hours from minutes. So when we wake up the device, as I said, we'll display the time. We can use, and also these LEDs indicate which setting we are checking right now. So this is the clock as mentioned here. And if we use the buttons left and right, we will go to scroll to open time setting and close time setting. So right now the open time setting is 7:30 in the morning, and close time setting is 18, which is 6 p.m. And we can use these buttons to scroll these times. This LED, green LED here, indicates the current status of the blind, so it is open now. When the device closes them, it will turn off. And this is important when the user detaches the wand and then later on reattaches it. The user can use the LED indicator to synchronize the status of the LED with the device, so that the device would not attempt to close the blinds when they are already closed, or the other way around. So we're waking this now, and if we want to modify any of these settings, we just click this button again, and then the hour will start blinking, and we can use the up and down buttons to change them. Okay, and also it has a click hold function to quickly scroll the numbers. this function was also built into the device, and when we were satisfied with the current setting, we click this the wake button again to adjust the minutes, and then when we're satisfied with that too, we just click the button to fix the setting. We can do the same thing for the open time and close time. I'm going to change the close time now, the open time 8 in the morning. And when I click OK, so for the open time and close time setting, these are saved in the permanent memory in the EEPROM of the device, of the microcontroller, so that if the user changes the battery in the future, they can have the same settings stored in the memory already. The device also has some error capture and status monitoring functions. When the device activates the motor, it gets feedback from the tachometer. And if it notices that the motor is stalled, there's no progress, or the motor is turning too slow, it will register a motor error. And also it watches the level of the batteries, and there are two levels. There's low level and there's dead battery level. At the low level, the device will still function normally, but it will give notifications, a beeping sound from the buzzer. And when it hits the dead level, then the motor function is disabled. And when any or both of these errors are registered, then the device will give a periodic beeping sound every 30 minutes in the notification period of the day. So the notification period of the day is only software configurable, and so the device will only beep in these hours of the day, and it will basically turn off the beeping function in the nighttime. So the current setting is, I think, from 7 a.m. to 10 p.m. And also, so this is basically to give notification to the user that something needs attention. And when the user, in case there are errors registered when the user clicks the wake button, if there's a motor error registered, and it will display ER, and also it will turn on all the LEDs. And if the low-level battery is displayed, is registered, it will display LO, the letters LO. And if both are simultaneously existing, it will display LO and turn on all the LEDs. I also like to mention that the low power function turned out to be exceedingly good. You see, this pack of batteries I installed, you see here the mark, it says January 1st, 2021. I put these batteries brand new, they're Duracell, and they measure 6.66 volts when they were brand new. And just a few days ago, I checked it, and they were still 6.5 after almost 7 months of use. So based on my calculations, this device the battery life should be anywhere between 2 or 3 or even more years. So that's impressive. Also, I probably forgot to mention that if we wake up the device and hold the wake button, it will manually toggle the status of the blinds. So it will close them if they're open, or the other way around. So I'm just going to give it a try to show the device functioning. So we wake this, and then we hold it, and here we go. And now when we wake up the device, it's closed, so we will not see the green LED turn on. And we can do the same thing again to open the blinds again. So the number of turns that this turn is fixed is only software configurable. Yeah. This device has been carefully programmed, and all scenarios have been taken care of. So it's been functioning for 7 months with absolutely zero problems, no bugs. Everything has been considered. The buttons have been well debounced by software. And for example, if the user tries to click more than one button at the same time, nothing will, no problem will happen. Basically disable the other buttons when it detects one is closed, and many things have been considered. So the project is 100% successful. Well, it still though needs some casing, proper casing, but this is probably going to be done later. Yep, I hope you liked my project. Thank you very much.